Is a zero vector a subspace of Rn? So starting with a real cutesy example here to warm us up. So, what are we given? Well, we are given that we're working with a vector space, Rn. And what is it that we want? Well, we want to show that the zero vector is a subspace of Rn. Right, so this is what we want to show here. We want to show that the zero vector is a subspace of Rn. And so we know that we have those three properties that we need to show hold true. So case 1 is the zero vector in the subspace H. Well, of course it is. Right, we're defining our subspace as a zero vector, so of course the zero vector is in the zero vector. Perfect. So case 1 is done. Case number 2 is the zero vector closed under addition. And so let's think about this. We want to show that for all vectors u and v in this subspace, we want to show that u plus, or vector u plus vector v is also in the subspace. And what's nice about this is we only have one vector to work with. All right, so is this closed under addition? Absolutely. We can say for all zero vectors in the subspace H, the zero vector plus the zero vector equals the zero vector, which is in H. So yes, this subspace is closed under addition. Case number 3, let's give ourselves some more room, is the zero vector closed under scalar multiplication? And again, let's start here by thinking about what we want to show. We want to show that for all vectors u in our subspace and for all scalars c, that the scalar multiple c times vector u is also in the subspace. So is this closed under scalar multiplication? Yes, it is. We can say for all zero vectors in the zero vector, which is our subspace H, and for all scalar c, the scalar multiple multiplied by the zero vector is equal to the zero vector, which is in the subspace H. And so therefore, since all three conditions are met, the zero vector belongs to the subspace, the vectors or the subspace is closed under addition, and the subspace is closed under scalar multiplication. Therefore, the zero vector, which is our H here, is a subspace of Rn. Woohoo!